In this tutorial we're going to walk through the steps to acquiring a Z stack with the multi-camera array microscope, also known as the MCAM. First, place your 96 well plate with zebrafish into the MCAM. Please make sure the well plate is oriented correctly so that well A1 is in the top left corner. Next, open the MCAM acquisition software. From the Assays toolbar menu, select Acquire Z Stack. Select an alignment file to tell the software where wells are located. For most systems, these files should already be saved on the desktop in a folder marked Alignment Files. These files are specific to each MCAM and each well plate. If you need to create a new alignment file, please see the tutorial on well alignment. For this tutorial we'll select a well alignment specific to our 96 well plate, and we can see indicator circles pop up on the screen in blue. Select a file location to save the acquisition. Most importantly here, we need to save data to the MCAM data drive, which should be bookmarked on your system. This is a high-performance solid-state hard drive that can read and write data at high speeds. Once a file location is defined, it will show up here in the Analysis panel. If needed, you can change this location by clicking this icon. Next, give the acquisition a file name. A timestamp will be automatically appended to the file name so you can take multiple acquisitions without changing the name in between. Click Stream All Sensors so that we can see what is happening under the microscope. Currently the full camera sensor array is visible, but if we only want to acquire a Z stack from a subset of the camera sensors, we can click Select Active Sensors. Click once to define one corner of the subset and again to define the other corner. If we wanted to acquire a Z stack from one camera, we could just double-click on one sensor. When we click Stream Active Sensors, only this subset will stream. To optimize the image on the screen, we'll use the left side panel. In the top left corner, select High Resolution and then Stream All Sensors. Next, adjust the Z stage height to bring the fish into focus. Just a note on image adjustments here. We are not going to modify these settings. These settings only control what you see on the screen but not the actual data we are acquiring. One common issue we see is users modifying these values, and then when data is acquired it looks differently than expected. We could change the minute level to highlight something of interest on the screen, but then when the data is acquired, it actually looks like this. The image adjustments available here can easily be implemented after acquiring data if necessary for your analysis, but for now make sure these settings are at their default values of 1, 1, and 0 before acquiring data. Next, we'll define the image acquisition settings. For the Z stack, you need to define your starting, middle, and end heights. These should span the Z range of interest, encompassing all the Z planes you want to include in the final acquisition. A good rule of thumb is to define your mid-height as your optimal focus, where most zebrafish are focused. Then, set the start and end heights 1 mm above and below the mid-height value, respectively. However, ensure that your start and end heights are the extreme points where you can see any sample in focus. Then enter either step size or number of steps to determine the Z-axis resolution. The second of these two parameters will update automatically. The start delay is the time we want to wait between initiating the acquisition and when the image is actually taken. There are also two save modes available. You can choose to save your data as either a.nc file or a.tif file, depending on your preference and post-acquisition processing requirements. For more information on the difference between these two file formats, please see the tutorial video on acquiring an image with the MCAM. Finally, you have the option to set up a stack projection. Projections are a way to combine many Z frames into one. It selects pixels of a desired intensity from every slice throughout the volume to construct a 2D image. This parameter will be set to none as the default, but it can be changed if needed. For more details on how to do this, please watch our stack projection video. The full acquisition set up, let's save this protocol so that we do not need to set it up again. At the top of the panel under Assay Protocol, click Save, choose a save location, give the protocol a file name, and then click Save. This can save time but also ensure repeatability of the assay when we use it again in the future. Once everything is ready, click Acquire Z-Stack. You will see a status bar preparing and then acquiring the Z-Stack. Once the dataset is saved, a pop-up will appear on the screen notifying us. If you have any remaining questions on acquiring an XYZ stack on the MCAM acquisition software, please contact us at help@Ramona Optics. Thanks for following along and see you at the next tutorial.